All right, section 5.2, we're talking about the uniform distribution. The uniform distribution, that means that all the values have the same probability of occurring. It's all uniform. Okay, some properties of a uniform distribution. It has the probability density function of 1 over b minus a, where x is between a and b. This is the shorthand version of describing the uniform distribution. This really basically says the distribution is uniform, with A being the lowest value of x and B being the highest value of x. To find the mean, what you would do is add A plus B divided by 2. To find the standard deviation, you would take the square root of B minus A squared and then divide it by 12. Okay? So this is what your your uniform distribution will look like. It'll look like a box or a rectangle. Okay, so if we went back to classical probability, the probability of x would be the number of ways event x can occur divided by the total number of possibilities. Okay, so find the probability that your friend is exactly 12.943823 minutes late. Okay, so say this went from 0 minutes, okay, they arrived on time, to 30 minutes late. So these are all in minutes. Okay, so number one, let's write right here. We'll say that that is the 12.9483 or 38. Got those backwards. 3823. Okay. Well, how many times does that exact number occur? Well, it's only once. Okay. The number of ways this event right here, 12.943823 occurs just once. Divide by the total number of possibilities. Well, how many possibilities are between 0 and 30? Okay, the answer is not 30 because you could have 29.9 seconds or minutes, 99 minutes, or 29.999 minutes, or 29.99999. I can keep on going forever. Okay, remember, this is a measure of time or a duration of time. Therefore, this is talking about a continuous random variable. So that would be infinitely many. So divided by infinity. Or really just a huge number. 1 divided by infinity or 1 divided by a huge number. If you start out with doing 1 divided by 100, and then do 1 divided by 1,000, and then 1 divided by 10,000, 1 divided by a million, that number would get closer and closer and closer to 0. Okay? So that creates a problem for us. So to avoid this, having the probability of one event come out to 0, well then there wouldn't be any point of finding the probability if all of them are going to come out to 0. So to avoid this, we compute probabilities of continuous random variables over an interval of values. We don't look at the probability of just one number, but an interval of numbers. Okay, that's how we're going to fix this. Okay, so you've got two properties. The total area under the graph, or over all possible values of the random variable, must equal 1. So for this graph right here, the total area under that rectangle has got to be equal to 1. And the height of the graph must be greater than or equal to 0. Okay, that's just so we can find a probability. All right, now for your uniform distribution, remember A was the lowest number and B was the highest number. Well, to get this height, the height of this rectangle, it's going to be 1 over B minus A. Okay, if you looked at the distance between these two right here, Remember, B is the highest number, A is the lowest number. So if this happened to be 10 and 20, to get the distance between those two, you would take the 20 minus the 10. Or we're just going to say B minus A. Now remember back in section 5.1, we said for continuous variables, which is what we have right here, a continuous random variable, then area is equal to probability. So if I'm trying to find probability, then really I can find the area. So if we look at the area of a rectangle, that is length times width. Or in this case, we'll say length times height. Okay, so our length is B minus A. Our height is 1 over B minus A. Okay, so this is the same thing as B minus A over B minus A. So I have the same number and the same number here. It's like saying 4 over 4, which is the same thing as 1. So the area over the entire rectangle has got to be equal to 1. That's what it says right here. Okay. Now let's look at this one. Let x equal the time from when you are supposed to meet your friend until he or she shows up. Suppose your friend could be on time, x equals 0, or up to 30 minutes late, x equals 30, with all intervals of equal time likely. What's the probability that your friend will be between 10 and 20 minutes late? Okay, well, number 1, let x be the time. Duration of time, by definition, is continuous. Okay, and then over here, all intervals of time, equal time, likely. By definition, uniform distribution, all values have the same probability of occurring. So what they're saying here is all intervals of equal time likely, they're all the same. So really, this is talking about a uniform distribution. Okay, so it says it goes from 0 to 30 minutes. Okay, now what we're trying to find is the probability that your friend will be between 10 and 20 minutes late. So we're looking for this probability here. But remember, since this is continuous, we know that probability is the same thing as area. So if I find the area of that rectangle, then really I found the probability of being between 10 and 20 minutes late. Okay. So what I need is two things. I need the distance from 10 to 20. So that would be 20 minus 10 or 10. And I also need the height of this rectangle, which remember that's 1 over B minus A, or 1 over 20 minus 10, which is the same thing as 1 over 10. Oh, I'm sorry. That's not our B and our A. 1 over 30 minus 0, because this is our B and this is our A. So this is equal to 1 over 30. Okay, well, the area of this rectangle that we're looking for, if we do length times height, our length is 10, our height is 1 over 30, so this will give us 10 over 30, or a third. Okay, which you could change that to 0.333, and I'll keep on going forever. So you could say that there is a 33.33% chance that your friend will arrive between 10 and 20 minutes late. Okay, part B. It is 10 a.m. when your friend is supposed to meet you. There's a 20% chance probability that your friend will arrive within the next blank minutes. Okay, so it is 10 a.m. when your friend is supposed to meet you. So this is still between 0 minutes late and 30 minutes late. This is part B from this information that they gave us right here. Right here. Okay. So they gave us 20%. So from 10 a.m. up until some minute at a time. So all of these x values, these are talking about minutes. And that's what we're looking for, is minutes. So I'm looking for an x value somewhere down here. And it says it starts at 10 a.m. when they're supposed to be there up until x minutes. So right here, this is 10 a.m. when they're supposed to be there. So supposed to be there means they're not late. So 0 minutes late. Up until some x value. And the x value is actually what we're looking for. Okay, so between being there on time, it being 10 a.m. up until x minutes, you have a 20% chance of your friend showing up. Okay, so all of this in here, remember, probability is equal to area if we're talking about continuous distributions. So that means I have a area of 0.20. Just take this number and put it into a decimal. Okay, so the area in this rectangle is 0.20. Okay, now I'm looking for between these two right here. So I'm still going to look at the area of a rectangle is length times height. Okay, well this time they gave us area. This is 0.20. And then the length, okay, that would be an x minus 0 or just x. And then my height would be 1 over 30, my b, minus 0, my a, which would give us 1 over 30. So times 1 over 30. And what I'm really doing is I'm just solving for x. So I need to multiply both sides by 30. They will cancel out here. I'm left with x. So x is equal to 30 times 0.20, which that would give me 6. Okay, so I have a 20% chance that my friend will arrive within the next 6 minutes. Okay, and last one. The average amount of weight gained by a person over the winter months is uniformly distributed from 12 to 30 pounds. Find the probability of a person will gain between 15 and 20 pounds during the winter months. Okay, so minimum is 12, maximum is 30. We are looking between 15, so 15 and 20 pounds. So this is the probability or the area since it's a uniform distribution, and we're talking about weight gain as measurement. To get this height right here, that's going to be, I'll write it over here, 1 over 30 minus 12, which would be the same thing as 1 over 18. So the height is 1 over 18. All right, so the probability or the area, we length times height. Okay, I need the distance between these two. Be 20 minus 15, or 5. So that's going to be 5 times 1 over 18, which that will give me 5 over 18, or the same thing as 0.28. So there is a 28% chance of a person gaining between 15 and 20 pounds during the winter months. And that's it.